time. So thank you all for making the time this Friday to join us for CAP's Methods Core presentation on using multidimensional IRT latent transition analysis and Markov models to examine. And this title's so long, I don't even have it all on my screen, so I have to move it to my main screen here. So using multidimensional IRT latent transition analysis and Markov models to examine the longitudinal associations between intersectional stigma and HIV outcomes. So the story here is that I'm a co-author on a paper with Andrea and Bulent, and I was so impressed with the methodology and the write-up and applicability to HIV research that I invited them to share their approach with us. And this is a two-part series. So today we'll be discussing the conceptual aspects of the methodology and how they successfully implemented it using off-the-shelf software products. And then this fall, they've graciously agreed to return back to share with us our implementation, a specific package that they're working on that will make conducting this type of analysis more seamless and easier for the end user. So we're really excited about that. And so it's my pleasure to welcome both of them today. Let me go ahead and just share a little bit about their background. So Andrea, please correct me if I mispronounce your name. I'm Dr. Andrea Norcini Pala.
Perfect.
Thank you. Is an associate professor in the School of Public Health at SUNY Downstate in Brooklyn, New York. He holds a master's degree in clinical, social, and experimental developmental psychology from the University of Parma, Italy, with a focus on psychometric and internet-based research methods. Dr. Norcini Pala obtained his PhD in clinical health psychology, concentrating on the biopsychosocial factors affecting HIV infection progression from Milano, Italy. He completed a postdoctoral fellowship at the HIV Center for Clinical and Behavioral Studies, Columbia University, where he expanded his research to intersectional stigma and mental and physical health outcomes among women living with HIV and African-American men who have sex with men and live with HIV. In his subsequent appointments at Columbia University, he continued to develop and apply skills in advanced psychometric and research methods, including multidimensional latent class / transition item response theory, network analysis, Monte Carlo simulations, and Bayesian methods applied to pilot randomized controlled trials. Additionally, he has expertise in qualitative methods, which he is currently applying to design a technology-based intervention for African-American men living with HIV who have sex with men in order to address intersectional stigma and improve adherence to HIV antiretroviral therapy. More recently, Dr. Norcini Pala has begun work on AI models to apply in clinical research and teaching settings. So that's all really exciting. And who knows if maybe we could invite you back sometime to talk about the AI work that you're doing, which is something that everybody here at UCSF is very excited about these days.
Definitely.
Thank you. And it's also my pleasure to welcome Dr. Bulent Turan. He's a professor in the Department of Psychology at Koç University in Istanbul, Turkey. He completed his doctoral training in psychology at Stanford, just down the road from us here in the Bay Area, and his postdoctoral training in health psychology at UCSF. Dr. Turan examines how stigma and discrimination, as well as other psychosocial factors, affect different populations, such as people living with HIV, substance use, and epilepsy, or living as a refugee. He also examines intersecting stigmas due to race, gender, sexual orientation, and poverty in order to understand and address disparities in physical and psychological health outcomes. His research includes biomarkers of stress, such as hair, blood, and saliva samples for cortisol and alpha amylase. He also studies the mechanisms underlying the associations between social bonds and well-being. These include effects of attachment orientation, social support, and negative social evaluations in psychological and physical well-being. So that was a long introduction, but really fantastic to hear about all your work and your credentials. And we're excited to have both of you with us today. And so without further ado, gentlemen, please take it away. And we're really looking forward to hearing your talk this morning.
And I will talk in generally about intersectional stigma, and then I'll let Andrea take over. And I apologize, I probably won't be able to stay to the end because it's going to get very late here. It's already past 7 p.m. But we're excited to share this work with you. And yes, the title is mouthful, even for Thor's big mouth. It was mouthful, but bear with us. We think it's very interesting. Let's see what you think. So let me start with conceptually what stigma is. This sociologist Irving Goffman was probably the first person to theoretically talk about stigma, and he argues that stigma starts when a person has either attributes or identities or behaviors that can cause that person to lose social value. So these attributes, identities, behaviors are viewed as being deeply discrediting and reduces the person from being a whole person to a tainted or discounted person. So now stigma is very complicated. And so, for example, there are different dimensions of stigma. There's anticipated stigma when a person, for example, living with HIV. By the way, everything we talk about can be applied to other stigmas and other intersections. So we are going to talk about intersectional stigma for people living with HIV, but this work can have other applications. So anticipated stigma is when a person anticipates negative reactions, discrimination, or attitudes or prejudice from others in the future. Perceived community stigma is the person's beliefs, the degree to which negative attitudes exist in society, whether or not the person believes this. Experienced or enacted stigma, these are actual acts of discrimination or negative attitudes. And as we will explain, today we will focus on this. Just to simplify it, you could look at intersections of other types of dimensions of stigma as well. And then there's internalized stigma, also known as self-stigma, where a person internalizes negative attitudes or beliefs in society and applies these. So, for example, a person living with HIV applies these negative beliefs about people with HIV to him or herself. So we had developed this conceptual framework to understand the effects of these 4 different dimensions of stigma. And since then, actually, we should probably add another one, which is microaggressions to it. So this framework is an attempt to understand the mechanisms through which these different dimensions of stigma affect HIV-related health outcomes, like viral suppression and CD4 counts, through adherence to treatment, through these interpersonal mental health, etc. Mechanisms. So our research in the past 10 years or so has been about the different paths in this model. Now, this is all about stigma related to HIV. And as I mentioned, today we will talk about enacted stigma, also known as experienced stigma, acts of discrimination. To keep it simple, because then the concept of intersectional stigma introduces intersecting stigmas. So if a Black person living with HIV is also pregnant, is also poor, has these different identities or behaviors or attributes that may all be subject to stigma, and when they intersect, then you have double, triple, quadruple whammy. So now the intersectional stigma, up until recently, qualitative methods were the main sort of method to examine intersectional stigma. Quantitatively, it's a little bit difficult, but that's why we're trying to use these interesting methods. So there are simpler methods, like you can measure stigma related to one identity, then examine how that stigma experience varies among individuals in various stigmatized subgroups. Or you can measure unique experiences of intersectional stigma only within a specific group. But when you have several types of stigma within the same person, then what you want to do is you want to measure all of these. Now, when you want to measure all of these, you can either have parallel questions, measures. By parallel, I mean you ask the same question about HIV-related stigma or substance use stigma or sexism. Or, so that obviously has analytic advantages, but another idea is to use specific measures developed for each stigmatized identity or condition. So validated measure of HIV-related stigma, validated measure of sexism or ageism or racism. Now, of course, then they won't be really parallel, but they are validated scales. And we have used both methods in our research. Okay, now, one obvious solution to analyzing intersectional stigma, let's say stigma related to HIV and sexual orientation. So you could have two main effects and an interaction, obviously. So HIV relates to stigma, sexual orientation stigma, and their interaction, which it can be done. It's not always clear what the outcome is, but most importantly, it's fine if you have only two stigmas, but if you have four stigmas, then you have all of these two-way interactions and even three-way interactions, four-way interaction. It gets quite complicated. Another approach is to use the latent class or latent profile analysis. So this method allows us to examine subgroups showing different combinations of stigma. And we have been doing this together with Andrea, this a lot, latent class or latent profile analysis. So it's basically a person-centered approach, because you put different people into these different categories that reflect unique combinations of, let's say, 4 different stigmas. And then based on this assumption that different combinations of stigma may have unique effects. So once you identify these subgroups with different combinations, then you can, for example, you can see if these groups differ in, let's say, treatment adherence or viral suppression. So this is one example. So right now I'm talking about cross-sectional. As you can see, it's quite complicated even when examined cross-sectionally. And then the main topic today is longitudinal analysis. But here you can see 5 different groups of people living with HIV. So, the y-axis is their stigma levels on these 4 different things: poverty stigma, HIV stigma, gender stigma, and all right. So the y-axis is standardized levels of stigma. So
Okay,
0
now I
being
can.
Can you hear me?
Okay, now I can. I think it was a delay.
Oh, okay. All right. Well, my voice is coming all the way from Turkey, so okay. So for example, the first group, as you can see, has low levels of stigma on all 4: poverty, HIV, gender, race. Whereas the last category has high stigma on all of those. But then there are different combinations. So the second group, for example, has a very low gender and race related stigma, but others are close to the mean, etc. So you identify using this approach, you identify these 5 groups. And once you have done that, then, as I mentioned, you can see if these 5 groups differ on, let's say, ART adherence or viral suppression. So that's what we have done in this analysis. So, for example, does group 3 differ from group 1 in terms of ART adherence or viral suppression, which they do, as you can see. So you can see which groups differ from which. Again, all of this is so far is cross-sectional data. So then the question is, how about longitudinal analyses for intersectional stigma? And I will stop here and let Andrea take over to do that. Let me see, stop share. Are there any questions so far?
I have a quick question.
Yes.
So the cross-sectional, is that a portion of the longitudinal or is that a separate study?
It's the same study. It's the baseline. Well, let me see. We have several studies, but it is the baseline data from a longitudinal study. Is that the particular results that I have shown?
Okay, great. Thank you.
Any other questions?
Yeah, and maybe you guys want to address this later. I don't know, but I'm just kind of curious what your recommendations are for minimum sample size for this type of analysis, or is that too difficult to make general recommendations?
Andrea, do we want to wait to answer that question, or do you want to answer it now?
Well, someone I used to work with said that my usual response is it depends, because it's difficult to establish, beforehand. I think the best answer would be to run a Monte Carlo simulation and see if your actual data, the sample size will be, enough. Another aspect would be if your distal outcome is rare or not, because if it's rare, it becomes very difficult to use the prediction of the latent class or the classes. But though I will mention in my presentation, there are so-called bias corrections in some of the packages that I will just discuss that can help. And it specifically is it is a Bayesian approach to bias correction, which just adds or compares your current estimation with an hypothetical called virtual sample that has one additional observation, 2 additional observations. So essentially is it's testing whether or not your current data is a potential, a portion of a general population. Or there are other approaches such as the, ecological priors invasion methods. There are many methods, and that is to say that I don't think that sample size should prevent us from exploring intersectional stigma or any other any other phenomenon in using this method. I guess the rule of the larger the better, I think it's always good, but not necessarily feasible.
Great, thank you.
Yeah, of course. So the goals, we're just going to talk about these multidimensional IRT latent transition analysis, its application to intersectional stigma, but as Bulent said, you can apply it to any other variable. And I'm actually, I want to invite you, if you're interested, I want to invite you to think critically in terms of how can I apply this method to my field, your specific field, and feel free to ask questions or to stop me at any point. I'm going to talk about a little bit of the three-step approach. That is a method that helps to adjust for or uses a correction and the membership probability to estimate the association between the latent classes and covariates or distal outcomes. I realize that I will discuss just mostly strengths because yes, I can mention a couple of limitations, but I like this method, so I couldn't find the many limitations. And I will just give you an overview of the statistical packages that are available to run this kind of analysis. So I think that one of the things that our work, it's pretty consistent. It is that we are interested in associations, sure, but we are interested in identifying mechanisms and pathways. And I think this Markov chain method is particularly useful to identify potential pathways and mechanisms. And that is to say that we know that stigma is a fundamental cause of health disparities. And because individuals can experience multiple types of stigma, and the interaction between the intersection of these multiple forms of stigma will increase dramatically the effect on health outcomes. It's critical to identify what are these mechanisms through which the intersection of multiple forms of stigma lead to poor health outcomes. As Bulent said, we'll talk about specifically experienced stigma, but our method can be applied to pretty much any other stigma process. Now, one thing that I always invite people to do is to not be afraid of complexity. And actually, we need to address complexity because we are complex social beings. And as Bulent said before, using the interaction terms sometimes can be helpful, can be useful, informative, but it can be difficult to parse out the nuances of these interaction and interplay between these stigmatized identities. So the research methods to understand these experiences are extremely important to understand the complexity and the multidimensionality of intersectional stigma, as well as the way that intersectional stigma can affect the health outcomes. And there, through these kind of studies, we can identify key intervention. I will try to be as impartial as possible, but I am not particularly fond of the regression models with interaction terms because, as arguably, it's difficult to understand the nuances of, let's say, the different levels of intersectional stigma that are, or the combinations of these stigma that are a risk factors, for example, for poor health outcomes. The latent class approach has been quite popular in the intersectional stigma framework realm, although I noticed that there is a propensity to use dichotomized variables, that is low versus high, although because we don't have clear and established cutoffs, sometimes these cutoffs are pretty arbitrary. So again, this approach might limit our understanding of the nuances and complexity of intersectional stigma. Finally, structural equation models are not a way to examine intersectional stigma just because it assumes that these variables, in this case, intersectional stigmas, they have an additive effect rather than an interaction effect, a nonlinear effect. However, I do acknowledge that the structural equation models can be helpful to understand pathways. One of the things that I am quite obsessed with is measurement error, because we don't always test the effect of measurement error on the quality of accuracy of our results. And sometimes, or it's well known that, as we will see in a little bit, that the measurement error is way trickier than we think, and it could undermine the accuracy of our findings. The methods that I mentioned, in addition to not accounting for measurement error, they also overlook the unique contribution of each item of the intersectional stigma scales, because when you calculate the raw composite score of a scale, you assume that each item is equally important in assessing the underlying trait or construct. Whereas we will see that that's not the case, because as with the qualitative approach, we want to investigate the subjective perception and of single forms of stigma. And if you will, I don't want you to think that it's a stretch, but when you look at items, these items might represent some different forms of, let's say, discrimination, and how important each discrimination or form of discrimination is in measuring the underlying construct can be achieved through the method that we will talk about today, the multidimensional IRT model. And also, as I said, they don't account for nonlinear relationship between different experience stigmas. Now, we need to lay some foundations to understand why we want to use the multidimensional item response theory combined with the latent class or the latent transition analysis. Now, to understand the transition analysis, we need to start with the latent class, because the latent transition analysis is an extension to the latent class analysis. So the MLCIRT, it is I like to think that it's a hybrid method that kind of taps into the best of the two worlds. That is, the linear models that are like the structural equation models or the item response theory, and the latent class. So the mixture models or the person-centered approach. And it's helpful to identify homogeneous subgroups of individuals. In our case, we identify classes based on the combination of different types of intersectional stigmas. And specifically, within the class, there is less variability compared to the outside, so the in-between classes. So LCA, the latent class analysis, combined with the IRT model, helps to maximize the within class homogeneity and maximize as well the difference between classes. In addition, it accounts for measurement error and each item contribution to measuring the underlying construct of or traits. I'm using constructs and traits just because the IRT folks use traits, the classical theory, test theory folks use constructs, but essentially we're talking about pretty similar things. So we, just to be very self-referential, I'm just going to use the example that Bulent used and focus specifically on the experience HIV, sex, racial, and poverty-based stigma. And I love plots, so I created this plot that it will come up quite often. So you see this called baby blue ellipses are latent factors, and latent factors are assumed to be continuous standardized variables. But these factors are inferred from a set of items. In this case, you see items are the 12 items for HIV stigma, 13 items for sex stigma, etc. Now, at the very top of this hierarchical model, although it's flipped, it should be at the very top, but you see that we have intersectional stigma, that it's not a latent trait, but it's rather a latent class model based on the latent traits. So why are we interested, or why Andrea is so obsessed with measurement error? Well, you know, we are taught, at least I think, it used to be at least, that loadings, standardized loadings greater than 0.4 are considered acceptable. Well, okay, so if that's the case, for example, here we have HIV 10, the item HIV 10, has a 0.48, let's say. When you want to measure the measurement error, conceptualized as the proportion of the variance in the item that is not related to the underlying trait or factor, you square the standardized loading, and that will result in an estimation of the proportion of the item variance explained by the latent trait. In this case is 0.233. Well, it's pretty low. It means that 23.3% of the variability in the item 10 is attributable to the latent trait, whereas 76.7%, it's noise, random variability that is unrelated to the underlying construct or trait. So if you sum up these items to create a composite score, you see that the very last column with the error, all of these errors are summed up into the composite score. It is true that we assume that the error, it is supposed to be random, so it ends up being approximately 0 on average, but it's not always the case. And actually, measurement error leads to attenuation of correlation or bias towards the null hypothesis, which means that if we want to get to the, if you're familiar with psychometrics and with psychometrics language, the true value, the true correlation, the true relationship between variables, we need to account for measurement error, because otherwise we underestimate the association or the relationship between variables. Now, while the standardized loading was from the classical test theory, we want to go a step further with the item response theory. Why? Because, well, while the standardized loadings can tell you how strong is the association of a given item with the underlying construct, and how, let's call it, how important is a given item in measuring the underlying construct. It doesn't really tell us much more than that. Whereas the item response theory, it gives a very nuanced understanding of the importance of each item and the underlying construct level. A, in this case, the column A, it is called discrimination parameter. As a paradox, we talk about discrimination, and item response theory has the discrimination parameter. And it is a reflection of how well a item measure or can discriminate between individuals with different levels of, in this case, HIV, experience HIV stigma. But we also have the thresholds or location parameters that is essentially how many response options we have. In this case, we had 4 on a Likert scale. Well, with the IRT theory, we have the number of options minus 1 location parameters, because they are essentially logic coefficients based on the probability of endorsing the first response versus the the second response versus the first, and then the third versus the first, etc. So you see, it is essentially at what level you have to be on the underlying construct to endorse a given item. And that's, if you see the numbers, they are -1, for example, -0.162. They seem to be reflective of a standardized distribution because they come from a standardized continuous distribution, that is the latent trait score, which means that if one item, in this case, item 1, has a B1 -1.308, it means that a person who has a level, let's say, of -1.308 is likely to endorse the first option of that specific item. And then it has to be at the level of -0.162 to endorse the second option, and then the third option. And the 0 is mainly the average of the overall sample of the underlying trait score. So in some way, in many ways, we are talking about, on average, what is the level of the underlying construct? And based on this average, how far from the mean a person must be to endorse the first item, first option? It's approximately 1.3 standard deviations from the mean. Now, while the previous slide was about the location parameter, this is about the discrimination parameter. As I said, it's how accurately an item can discriminate between people at different levels of the, again, discrimination, HIV discrimination. And you see, it's literally the slope of a logit coefficient, where the steeper is the slope, the more accurate, the better performance is associated with that specific item. And again, we have 4 options, response options, but in this case, we have 3 slopes. Again, because these are the thresholds, at which, after which you are more likely to endorse the second option, the third option, etc. Now, this is the first part, that is the items, the latent traits. But now we need to include the latent class part. So the latent class takes the information collected or estimated from the IRT model, and specifically the correlation, the covariance between the latent traits, to then identify different combinations of the stigmas levels. Now, does it make sense now why we are using 0 as a reference here? Because 0 is the average of the overall sample. So when we look at this plot, we can say that the first class has lower levels of all of the experienced stigmas compared to the mean of the sample. The second group the second class, they do have lower levels compared to the average. But when you compare them to the first class, they have a slightly higher level of experienced stigma. So the latent class, or the latent class analysis, in this case, the MLCIRT, can give you a reference that is the sample mean to interpret the classes. But you can also compare the classes level to name them, to characterize them. Now, the step from MLCIT and to MLTIRT, it's quite quick because the multidimensional latent transition analysis is just an extension, a longitudinal extension to the latent class IRT analysis, where the model that we use, it is the same as the one that I used before. We only include time as a potential or as a covariate. As I said, the latent transition analysis, the multidimensional latent transition IRT analysis, it is simply a longitudinal extension of the LCA. It estimates changes in latent class membership, which means that a person can belong to class 1 at time 1, but to class 2 at time 2. There is the option of being dynamic. So we definitely look at, examine the dynamic trend over time of the experience of stigma. Oops, sorry. In addition to identifying these latent classes, we do identify and estimate the transition probabilities. And as I said, they are literally, how likely is that a person who is in class 1 at baseline will be in class 1 at the follow-up? A very general model. MLTIRT is a dynamic process. It takes into account changes over time. You'll see that we have 4 time points here because this presentation is specifically based on the study, the doctors Turan's study, the WAVE study, that has 4 time points. And you see that time 0 is see a question: does it identify factors associated with the transition? Do you mean the, let's say, covariates that can affect the transition probabilities?
Yeah, well, if it's modeling changes in the experience of intersectional stigma, so you're in this latent class and you're moving to another one, does it have the ability to identify what's changed for, in based on the item responses or the latent measures?
I see what you're saying. I see
that sort of thing. Yeah.
So that's a very interesting question. I would say yes, but not based on the measurement model, where the measurement model, it would be the IRT model. Because in this, in the transition analysis, you can have a covariates that could affect the likelihood or the probability of being of transitioning from one class to another. I have to say that I personally find it challenging to find the covariates that to use to, to test, because many covariates could be, could
Multidimensionally
associated.
moving. Yeah. Yeah.
But that is not to say that it's not possible, because it is possible to do it as a post hoc analysis. Because I will talk about this in a little bit, but there is the option of doing the mover stayer analysis, that essentially you identify two classes of these longitudinal transition model, where you identify people who are overall staying in a class, whatever class it is, or move. Then you can do a postdoc test to see what factors can affect this probability. The other option here is that I want to mention, and I take this the chance to talk about this. You mentioned the change in the IRT model. This is true. It could change. However, there is a basic, I want to say basic, but very challenging thing to examine, that is the invariance over time. So the multidimensional latent transition IRT model requires that the properties of the measurement model should stay the same over time. It assumes that the ability to discriminate between higher and lower level, or the thresholds, they remain the same over time. And I will talk about this in a little bit, but it is computationally very challenging. Not impossible, but very challenging. I see that Tor says, is moving value question. That's true. It can, I agree with you. It can be, I guess, the identifying the movers and the stayers, it could be very helpful to inform or identify individuals who are at risk, for example, to experience high level of intersectional stigma over time. So if they reported at baseline, it's very likely that they were reported at follow-up or not, and we will see the transition probabilities. Do the classes themselves remain the same over time? Yes, they do. There is the option that it could be the option to have a variation over time. However, it's part of the measurement model. And again, the measurement model should be invariant over time. But again, partial invariance is possible. And there is the option of having time varying latent class, number of latent classes. Thank you for all of these interesting questions. Okay, so you see that we have 4 time points. Doesn't mean that we have 3 transition probabilities. No. The structure of the data that we used is 1 year apart in between time points. Now, that's also important to say, because usually we wanted to make it equally distant in terms of time, although it's possible to have an even distributed time points, because the variable time is treated as a nominal variable. I'm reading Tor. it makes sense that you'd want measurement variance over time. That means that you're measuring. Yeah, true. But along the, in line with what Edwin said before, it is interesting to test, even if there is not invariance over time. It's interesting because it can tell you what changed, or you can examine what changed, in a specific item. However, overall, we want to have it to be stable over time, also because the softwares available, I think only one allows or can manage non-invariant measurement models. The one that I personally use, Latent Gold, doesn't, and that's an unfortunate thing. But so as I said, we're not gonna have necessarily multiple transition probabilities, because the transition probability can be homogeneous or time homogeneous or time heterogeneous, which means that is the probability of transitioning from one class to another the same over time at each time point, or it changes with time? That's something that we test beforehand during the first step. It will make sense why I'm saying step. In our case, we had a time homogeneous model, which means that we have overall transition probabilities that apply to each transition from time 1 to time 2, time 2 to time 3, etc. So let's go with an example that is using the, as I said, the wave data that is part of the WISE or MaxWISE cohort. As I said, we have 4 time points, and we have women with HIV. This is the demographic, the sample characteristics. You see that I have T0, T1, T2, T3, where T0 is the baseline assessment, T1, T2, T3, I'm referring to the follow-ups, and you will see that T0 we will refer to T0 also as the initial state. We used different scales to assess poverty, HIV, sex, and racial stigma. I'm curious to hear, is there anything popping up, anything that is obvious to you looking at this slide that could make you question, is the number of items an important aspect to consider? Because, for example, the poverty stigma has 4 items, then we have a 12 item, and then a 13 item, and then a 10 item. It could be, but theoretically, if we want to go with the classical test theory, 4 items can still, if they are representative of the pool of all of the items measuring poverty stigma, we might be measuring poverty stigma accurately, whether it's 4 items or 5 or 6 or 10 or 20. In this case, it's not always the case that the more items, the better. it is the opposite, in my point of view, because sometimes having more items will lead to more residual variance that is due to, for example, unrelated factors that it could be, once again, noise. So when we analyze the data longitudinally, we found exactly the same, or very close profiles. We found 5 classes exactly as the cross-sectional study. We found that the levels of the intersectional stigmas, they are pretty similar to the cross-sectional. There are just minor changes, but again, it could be a reflection of the package because I used 2 different packages. But at the same time, it could be just that cross-sectionally versus longitudinally, there is a difference. And I want to go back to say that these profiles remain stable over time, which means that even though I'm reporting the N and proportion at that we observed at baseline, the same profiles can be found or are applicable to the first follow-up, second follow-up, and third follow-up. Because imagine that the data is structured as a long format and not as a wide. Oops, sorry. Now, let's go to this table where we look at the transition probabilities. Now, let me help you with this. Class T-1 to the very left of the screen. It is the class at the whatever previous time point. It could be T0, it could be T1 or T2. And at the top, you see class T, which means that row-wise, you see the probability of transitioning from one class to another from T-1, previous time point, to the following time point. Let's see, for example, the first is C1. If a person was in C1 at time -1, 63% of the women in class 1 at time -1 remained in class 1 at the follow-up. 23% or 0.23 women moved to class 2. But if you see class 1 and class 2, they could be considered overall as lower than average experience of stigma. The most interesting finding was that no one who was in the class 1 at whatever time point moved to C5. That is elevated levels of all stigmas. That goes, actually, let me not go that far first. Now, let's see the time, class 5, for example. 53.5% of women who were in C5, so elevated levels of all of the stigmas, at whatever time point, were likely to stay in the same class at the follow-up. 26.2% moved to the fourth class, that is high HIV and moderately high poverty stigma. Fewer, 12.4% moved to C3, that is moderately high poverty, gender, and racial stigma. Once again, oops, I didn't highlight that. But if you look at how many moved to C1, 1.4%. So very few women who were in the extremely high levels of all stigmas moved to no stigma at all, or very low stigma. Again, this speaks to the chronic aspect of experienced stigma. That is, we know that is pretty stable stressor. Exactly. I agree that I like it's sticky because it's really, you know, it's a chronic, I would say, state of living, because there is this the social self or the social self-threat theory, social identity theory. It says that if you experience a lot of discrimination, you become more sensitive to neutral or sometimes even positive interactions, even if they are ambiguous, if you're not sure, or if there are potential cues of discrimination, then you tend to react and interpret any kind of interaction as potentially stigmatizing, which means that it does not mean that it's not happening. It is, because, you know, stigma and discrimination, it is a subjective experience, and it causes a lot of stress regardless. Structural, big environmental changes can impact stigma, moves, incarceration, for sure. Absolutely. And I agree, Tor, that the data source may be a long-standing cohort, which means that participants may be stable. Oh, that's a very good point. What would happen if this type of analysis were applied to newly diagnosed persons? That's really interesting, because it will also, you know, it would also speak to the theory of the 1 month adjustment after the diagnosis. It would be really interesting. Did you set the number of classes, or is this something that not informed, or both? I'm curious to. Okay, so okay, I really like this question. So did you set the number of items, sorry, of classes, or is something that the model informed, or both? It's both, because there is an issue with, at least in my experience, and again, I'm open to discussions about this. Cross-sectional data, it's easy. In cross-sectional data, it's easier to identify the number of classes using the fit indices. Usually, you know, the AIC, BIC, adjusted BIC, and the log likelihood tests. In longitudinal data, and specifically in the latent transition models, when we use a measurement that is a IRT based, it's very difficult to to see a neat and distinct, change in the AIC-BIC. That is, it tends to have to try to account for as much variance as possible. So you technically could go and extract a lot of classes, even though it might be just noise that you're accounting for. And this is one of the limitations that I do realize that is part of this method. That's why it's important to consider the literature and how informative each class could be. And specifically, one thing that we found in this study is that we could have extracted a sixth class, but it would have been essentially a subclass of the fifth, where the level of intersectional stigma was above the mean, but it was pretty much, equally high. At that point, you can say there's no point in extracting six classes, because it's still, the sixth class is essentially part of the fifth, that is higher than the average experience of stigma. Collapsing, if the data show you that, or suggest that you have 5 classes and they are pretty distinct, I don't know if it's necessarily a good idea to collapse. However, there is a tree approach that is essentially you have a sort of a hierarchical model where you have high versus low. Everything is high, everything is low. And then within these classes, there are multiple classes that will have the different distributions that you can see. In that case, it is based on the model, it's based on the data, that is different. But that's actually a very good observation and question. And specifically, one of the challenges is to, find the best fit index that can help us identify the optimal number of classes. So far, I rely pretty much on the entropy and the classification error, but the AIC, BIC, and adjusted BIC, they are not really informative, at least in my experience. Now, all of this is great, but is computationally intense. So if we want to measure or test the association between these classes and the any outcome or a covariate, we should use the 3-step approach. And the 3-step approach, it's way easier than the 1-step approach, where you test essentially the association between classes and any covariates, because the introduction of the covariate in a model, in a latent class or latent transition analysis, it changes the membership, the class membership, or the posterior class membership. So first, we want to build the latent class or transition model. Then we want to test the association between the classes and the covariates or distal outcomes. Unless you want to account for the covariates as potential predictors or factors that could predict or influence the membership, that is totally feasible. But it has to be a priori or a theoretical, let's say, theory-driven decision. What are these 3 steps? Well, first, we build a latent class transition model, and we determine the most appropriate number of classes. Again, this can be a little subjective. However, I would say that the parsimony used a lot of good judgment in a way, because we might end up sometimes extracting a lot of different classes because we want to see we want to identify all of the possible combinations, but are they really meaningful? And that goes back to what I hope I pronounced it correctly, Naya said, does it make sense to have 5 versus 4 classes? So the principle of parsimony is always a good one to go for, to choose the number of classes. For sure, the fit indices, I would still use them, although I wouldn't necessarily base my decision on only on them. But once we identify this model, what we do, we simply save not the class or what's called the modal class membership, which means that you assign a person to the class with the highest membership probability. You use all of the membership probability because you want to account for uncertainty. Because when we assign someone to a class, it is a probabilistic approach. It is it's not deterministic. It's not 100% sure that this person belongs to class 1. It can belong to class 1, but to a lesser extent can be in class 2, 3, etc. That's again to take into account uncertainty, because that's actually the second step. You or the software runs the analysis using the membership probabilities. And one approach is using the plausible values. That is, based on the probabilities, you run multiple times you run the analysis multiple times, changing the probabilities of being in one classes versus the other to take into account the uncertainty. I don't think there is I want to say, in the second step, is there a minimum number of participants to be assigned to each class that is needed for a valid analysis? Or is the wrong question? No, it's not. I don't think there is a wrong one, right? This is a great question, and it goes back to what Tor said, asked before. Is there a minimum? If we go by the Mutin, who is the founder of M+, Mutin and Mutin, they suggest at least 10% of the max of all of the sample. So if your class is less than 10% of the overall sample, maybe it's too small. There is another publication suggesting something similar. However, I personally like the answer by, again, Ben Mutin, who says potentially in a large sample, even 1 or 2% of the sample belonging to a class, it could be informative. I would not necessarily disregard or discard this information on this class just because we have fewer participants. I would not necessarily use the model as a final model, but rather potentially as a sensitivity analysis. And also, it really depends on the power that you want to have in terms of, a smaller class could lead to a, let's say, weaker in terms of power prediction in a subsequent analysis. So I would say I would stick to the 10% rule of the overall sample and to the judgment of what is this additional class is providing you that the other classes don't. So third, the latent classification are related to the external variables. So essentially, first identify you use the model, the measurement model, to identify the best, the most appropriate number of classes and the characteristics of the classes. Then you extract the membership, the prior membership, and you use it to assign people to any of the classes based on the prior distribution of their membership. And then you actually test the association between latent classes and the outcome. One thing that I think it is really exciting is this analysis was ran in Latent Gold. Latent Gold, I don't get any incentive for saying this, but Latent Gold, it is an exceptional software to run this kind of analysis and very, I would say very user-friendly. And it has all of the steps fleshed out, and I would say that as your model becomes more complex, it becomes computationally becomes really difficult to get a stable solution or a stable model. So it's important to consider, to examine and diagnose the fit of the model. So for example, running with random starting values or with multiple bootstrapping. Those are aspects that are still unknown, but important to explore to see if you consistently find the same number of classes. But what I like about the three-step analysis implemented in Latent Gold is that you don't need, even though the latent class model, it is a nominal variable theoretically because it is considered not ordinable. Even though you have a nominal variable, you don't have to have a reference group. You can have a sort of a multivariate ANOVA and compare all of the classes with each other. Of course, you need to adjust for the p-value, but this is really interesting because at least you can see the differences across all of the classes rather than focusing only on one class as the reference group. If you remember, I said T0 or initial state. A lot of, well, let me not say a lot, but I can see that some researchers do not really pay much attention to the initial state association because it is cross-sectional. Essentially, what you're doing is you're testing, if you see this model, at t-1, which could be, for example, the t0. You essentially test the association between intersectional stigma, ART adherence with viral load cross-sectionally. But at the same time, it is the initial state, which means that it is possible that if you didn't change, or the probability of moving from one class to another is very low. That is, if you have predominantly a lot of stairs, then the association that you see at baseline, or T0, is likely to be reflective of what happens over time. That is, if women, let's say they are in the 5th class that have a lot, excuse me, a very high level of intersectional stigma, they tend to be less likely to be adherent to ART at baseline. And if women tend to stay in the same class over time, then it's plausible to think that they also remain, they keep being non-adherent to ART. So we will not see a prediction over time because it's essentially the status quo. That is, the association cross-sectionally remains the same over time. And that's the case in our analysis. One of the cases. You see, the T0 association in this case is, as I said, the association of our variables at the initial state. So at the very beginning, we see that women in class 3 and class 5 and 4, so women who have, if you see this cute legend at the bottom, women that have at least 2 levels of experience stigma above the mean, they tend to be less likely to be adherent to ART at baseline. And we found consistently and very interestingly, the class 4, which is women with poverty and HIV stigma above the mean, we would expect them, because of the levels, to be, you see, to show a significant p-value that is way below 0.01 as for C3 and C5. However, compared to the first group, C1, you see that the p-value is 0.028. There is a high variability in terms of the odds ratios. And the probability, at least based on these findings, the probability of being non-adherent to ART is way higher, baseline again, for women who experienced poverty, racial, and gender stigma, 3.580. Then we have C5, that is the women who have experienced all of the intersectional stigma above the mean. It's 2.806, still with a very decent p-value. Now, when we look at the detectable viral load, we included in the model also ART. So above and beyond the effect of ART adherence, there is a difference in detectable viral load, or the odds ratio of detectable viral load for women who experienced poverty, gender-related, and racial stigma, compared to women who were in the C1 group, so with low overall experience of intersectional stigma. And that was the only group that differed significantly from the first group, the reference group. Interestingly, we found very similar findings longitudinally, though C3 and C5. So women who were in class 3 or 5 at the previous time point were more likely or had a higher odds to be non-adherent at the follow-up. And that was significant for, as I said, C3 and C5, but not C4. When we look at the prediction on detectable viral load longitudinally, we didn't find any direct effect, although, I mean, the C5 is the odds ratio are approaching significance, so maybe it's a trend that we can marginally discuss, although we didn't necessarily discuss this in our paper. But there is no association between or any prediction in terms of latent classes predicting detectable viral load at follow-up. But I didn't report this. We did find that the prediction is significant when we include ART adherence as a mediator. Okay, so strengths of MLTIRT. It accounts for measurement error in observed indicators. It allows for examining both stability and changes in latent class membership. It definitely provides insights into the dynamic nature of experienced stigmas. However, as we said, in this case, experienced stigma seem to be quite stable over time. It will be extremely interesting to look at, for example, internalized intersectional stigma and see how it changes over time. Limitations. Okay, distal variables. Unfortunately, because it's a Markov chain model, we need to categorize, to dichotomize or recode any variable that is continuous as categorical, because again, Markov chain's model deals with categorical variables. Although it could be okay, I think sometimes when we recode or dummy code some variables, we could lose a lot of information. Another limitation is definitely that is computationally demanding. It easily can take long time to run, especially when you fine-tune the model and you use the bootstrapping. That is definitely the part that it takes the longest, but it's still worth it. There are multiple analytic steps, so that's definitely something that we need to account for. But I think that the most challenging thing is what we said before, and Andrea said, how do we identify a number of latent classes? So I refer again to latent gold, just because it is the one that I'm mostly familiar with. but it provides you with a pseudo Bayesian fit index or indices, because it could create multiple indices. And those are more reliable than, the competitive fit indices such as the AIC, BIC, and adjusted BIC. However, same thing, because they are based on simulations, it could take nearly forever to run. So if you want to use it, just be careful with how many replications you want to set. What are the statistical packages you can use to run these the latent transition? So latent gold, 100%, M plus, same. Although M plus has a slight advantage over latent gold, that you can run the latent transition with a wide format rather than the long format, which allows you to test the invariance of the measurement model. As Tor kindly said, we are working on an R package to run this model. Let's say that it's on the way, hopefully. If you want to run instead the multidimensional latent class IRT models, you can use, there are many different packages in R, and I'm just listing R because it's free and you can have access to it, but of course you can use latent gold or M plus if you have it. But the first two, MLCIRT within and MLCIRT, they were specifically created to assess this kind of models. However, it does not allow you to go further with the Markov chain, so the transition model. TAM is another software that is, another package that is really, it can be used for many different types of analysis, and I think it also allows you to have covariates in the model. And MIRT package, it can be used to assess, to estimate the model, which is called local LCRT, latent class analysis. In MIRT, they refer to the local LCA. And these packages can can be used for binary or ordinal items, whereas the SIRT, which is supplemental IRT package, is exclusively for binary items. However, it is extremely it is one of my favorite packages for sure, because it also implements the Monte Carlo Markov chain Monte Carlo approach, as well as the Bayesian approach to this type of models, and it can be slightly faster than the other ones and more stable than the other ones. I do have my acknowledgements to make. That is to Doctors Janet and Bulent Turan, that they are two fantastic mentors. And I want to thank all of the WAVE and CCS study participants and the investigators. And thank you so much to all of you for being here, to attending this seminar so early on Friday. And thank you, Tor, for inviting us. And thank you for your incredible feedback. I'm always very worried when you about your feedback.
Thank you for a really wonderful presentation detailing all the steps involved in this complex method, and some of the things you and Bulent and the team have been able to learn. It's really quite remarkable. At this juncture, we'll deploy an evaluation, and we ask that everyone please complete it, because we use that to justify our continuing to be able to offer these kinds of talks, justify to our funders. And meanwhile, I wanted to ask if anyone has any questions for our presenters after having heard the whole thing and having a chance to absorb it a little bit. See, Jesse has a question in the chat.
Is it possible, or how is it possible to use AI to enhance our understanding of intersectional stigma using MLIT? For some personalized intervention, do we have enough data for that? Okay, so I think, I don't think we will have enough data, or ever will have enough data, because I think we understand it's a dynamic process. So we will learn as we go. And I guess I want to say we will learn more as we go. I do think that AI, I think it is helpful, not necessarily to understand intersectional stigma, but it could be helpful to address. And I'm thinking specifically of a potential intervention. I'm not giving away a lot because it's part of one of the projects that I'm working on, but it could be used to a sort of a just-in-time intervention, that essentially an intervention could start just when the person needs it. And it can, help identify when a person needs this intervention based on certain parameters. I know it's very general, but I'm not giving away my potential proposal.
So you're thinking maybe, maybe at some point the model results could be built into something that could, for lack of a better term, be translated from bench to bedside. One thing that came up at our faculty retreat yesterday was an interest in things like personalized medicine or optimized treatments for people. And so one thing that's very appealing about this approach is that it is a person-centered approach. And so I was just curious if you guys had any thoughts about how you might be able to translate such a complicated approach to something that clinicians could use out in the field.
For example, if you think of the transition probabilities, and we see that women women who were at a certain time point were in the class with the highest level of intersectional stigma. Very few of them moved into the no stigma at all, which means that if you feed this to a model, it could, what I say, touch base with them, in between visits. And whenever there is a potential, distress arising, it could either inform the clinician to touch base with them, or to invite them to a external resource, or it could potentially start a assessment, because you can, let's say that there is a touch base with a patient, and is just the 2 items, PHQ-2 or the GAD-2, or anything that it could be related to something, even MemCaps, if they are using MemCaps, and you see that, the AI is registering some kind of reduction in adherence, it could trigger a oh, I need to touch base with this person and understand what's going on. That is the just in time. I want to also, I see that Edwin said a major issues is the field around AI is inclusion. Yes. Now, it's true, but it's also true that AI does not stop learning. I don't want to talk about AI as a person, of course, but it is a model that is we feed a lot of information and learns as we go. So it means that potentially true, you know, there is a limitation in terms of who we include, but any following outlier, let's say, they will be included in the stage of learning, and it will be applied to the next step. So it doesn't not exclude outliers, let's say, or you know, new individuals. I do think that there is a lot of concern about AI, but I also think that whether we want it or not is gonna happen. So it's better to, you know, find a way to use it as best as we can. But I don't know, Bulent, do you have any insights?
No, not more than you.
I'm obviously biased towards AI because I found it very helpful, I think, especially in certain, you know, settings, such as, for example, the low income settings. It can be useful to, for example, one of the projects that I'm working on is among people living with HIV in Mexico. And in Mexico, people unfortunately cannot afford to go to a psychotherapist, but also there is a very high stigma towards who goes to, you know, mental health settings, etc. And AI can reduce these barriers. AI or technology-based interventions that are evidence-based, because we can fund an app and people living with HIV can use it to keep track, or, you know, as a cognitive behavioral therapy. And again, full disclosure, I'm designing an intervention that is online, so I am partial to it. But at least I think that when patients are not coming, we have to go to them. When they are not going to the visits, maybe we have to find a way to go to them and see what is going on, and, you know, how can we improve the services. It could be helpful for a forthcoming application to have a way to score news based on. Oh, that's true. Funny enough, there is the option, scoring option in Latent Gold. I need to explore that, but that's a very good point. Yes. So Jesse, there is, it seems like I'm selling a lot of stuff today, but I'm not. There is a incredibly helpful, it's not free, but it's called Claude, an AI. So CLAUDE. It is a AI that is quite helpful to do some kind of qualitative analysis, or even, you know, cleaning the interviews and transcripts. It is really, it's very interesting, and it's way better than ChatGPT in terms of, you know, what the products that returns. Funny enough, you can feed in a paper with a lot of equations and ask the AI, can you just simplify and explain these equations for me to use it? And it will do it. Yep, Claude. And I think also Adobe, the PDF, Adobe PDF, I think Acrobat has the AI included, and you can just ask questions about a paper and it will return an answer.
Yeah, that's pretty amazing. We have we have a tool at UCSF called VersaChat that they've set up for us so that we can, it's a protected space, so we can feed it research participant data safely. I don't know how it is for digesting equations and complex formula. I should give that a try.
So for any of you who didn't or haven't had the chance to use ChatGPT, you can use it, I think, on iPad and on your iPhone. You can use it with a vocal setting, and you can literally talk with the AI. And I keep saying this to people, and I think you haven't heard this so many times, but when it was a day that I was in Mexico doing my things, and I don't know, I was asking, can you give me an example of the self-affirmation theory or self-affirmation approach? Vocally, this person, who, by the way, had the voice exactly identical to my psychotherapist, which was something that was quite, oh God, I said, okay, this is so weird. And the AI asked a follow-up question. Asked me, are you considering using, or testing this self-affirmative approach? And I was a little taken aback, and I said, well, I don't know. And the AI actually probed more and said, well, this could be a way for you to explore, et cetera, et cetera. And at first I said, well, this is scary, but also I kind of focused on how did I feel when I was interacting with it? And I'm thinking, what would it be? Would it be beneficial at all to a person to talk to AI? Even if you know that it's, an AI, would it make any difference if you can train a sort of virtual counselor? Although I agree that we need to have a person behind to check that if there are any risks, imminent risks. But I think there are so many. There is a huge potential there, especially in, again, settings such as Mexico or other places that are difficult to seek help.
Right. Yeah. And there are a variety of reasons for that, resource limitations as well as stigmas.
AI counselors seem to gain traction worldwide due to a shortage of human counselors. That's true. But also, I think that, and again, I keep referring to Mexico just because I have experience there. It's not like in the US that you have a insurance and you can go to a psychotherapist or a counselor. Over there you have to pay out of pocket. And the question there is most of the times it's surviving because of how high is the cost of living. I think it is, I'm gonna be very annoying and very activist here, but I think it's our responsibility to provide the best that we can to people who are in need. And that's why I cannot disregard the AI as a potential, intervention. Oh, that's interesting. I didn't know about that. There is a preference of interaction with an AI instead of a human doctor. It would be really interesting to see if a interaction, in-person interaction, and AI interaction will lead to the same changes, or like reflection on oneself, or even physiological changes, such as more calm after the meeting with the interaction with the AI. And at Downstate in Albany, though, there is a Center for AI applied to mental health, which again, whether we want it or not, it's happening.
Yeah, some of the discussions I've seen around this has been that, if we can use AI as a sort of front end to unburden or at least reduce the burden, to be able to be compassionate, because they'll be less burned out, and people may, then feel better talking to their providers than they might in a situation where the provider is just frantically running from one patient to the next and sitting in front of their computer, facing the computer instead of facing the patient, which is a big deal. But I was really happy to see you including poverty stigma in your work, because you mentioned that people may not have the resources to pay for counseling out of pocket, and I think then the poverty stigma is can be layered on top of that. So it's really nice to see that included in the. All right, well, I see one new message. Yep, okay, an enthusiastic thank you from the chat. Thank you for coming, Jesse, and thank you both, Bulent and Andrea, for presenting. This was really wonderful, and love the integration of the HIV research topic and the sophisticated methodology. And I'm really looking forward to part 2 in the fall, when we learn more about the R package and all the amazing things it can do. And I think that that's going to be such a fantastic contribution, because you'll be, somebody who wants to sit down and do this won't have to kind of borrow a little here and a little there from different packages and kind of try and stitch it together. So you guys are doing a real service to the research community by coding up that package and rolling it out.
Thank you. And feel free to reach out if you have any questions or any suggestions. Very open to discussions.
Great. Well, thank you both, and we'll let you get to bed now. You made it the whole way, so thank you. We appreciate it.
Thank you, Tor.
Say hi to
Thank you,
Janet and
guys.
everyone.
Yes, I will. Okay.
Okay,
Thank you
thanks
for
everyone.
inviting us. Bye.